The Creative School is aiming at providing one of the leading international schools for over 1,700 international students between the stage of early years and sixth form. The Creative College experience encourages the worldwide students to grow in an integrated, academic, international, and inspiring environment. Sustainable concept is a key focus of the Creative College, and the environmental design of this project must meet the criterion of passive house. The total site area of this project is 100,000 square meters, with the total building gross area no more than 25,000 square meters. The limitation of the height is no more than 3 stories. The site is situated in suburban Bristol, a city located in the southwest of England. We consider different strategies through analyzing the climate feature of Bristol. The climate is quite warm and moderate. The average annual temperature is 9.8 centigrade. The solar resource is quite adequate in summer, and there is no overshadowing from the immediate context around the site, which makes the use of solar resource a good option. For rainfalls, as moderate rain accounts for the largest proportion, strategies for rainfall harvesting is considered in our design.
The site area is currently used as an open ground for sports facilities. The context has 2-storied residential buildings forming the boundary and a community clubhouse at the west edge. The main goal of Creative College is to provide an integrated, multicultural and sustainable learning environment. Therefore, our design concept evolved from various functional requirements of the college and the environmental aspects of the site. The massing is distributed into primary school, secondary school, library block, dining and workshop spaces and shared spaces or public zone. The topography of site is sloping with highest ground level at roughly +7 meters from the lowest ground level. This influenced our design decision to locate primary school at the lowest level for ease of access and secondary school and other spaces on the higher ground levels of the site. The design is required to have some facilities open to the public. Therefore, functions such as the swimming pool and sports facilities have been located away from the main school close to the existing clubhouse. Additionally, similar functions such as the auditorium, theatre, music and art rooms are integrated with the shared spaces. This promotes public interaction but at the same time restricts access to the main school. Each block is interconnected by continuous courtyard space to encourage interaction among students of various ages. The site also has many existing deciduous trees which can be incorporated within the courtyard environment. The library forms a centralized space between secondary and primary school. Typical floor plan of the school has classrooms, staff rooms and labs accessed through corridors interconnected by common areas. The classrooms are oriented to face north-south with openings on either side for good daylight reception. This reduces the need for artificial lighting. Design considerations such as corridors on the south facade and shading devices on east and west facades reduce solar gain and shade from direct sunlight.
Using the energy hierarchy, the design could be made more energy efficient, which is reducing energy demand, increasing energy efficiency, and using renewable sources. We have used many passive house design strategies to reduce energy demand. Firstly, our building uses high thermal mass material with the low U value. Compared with the Part L regulation for wall, roof, floor, and the window, the design U value is much lower than the standard, which could significantly reduce the energy demand. Secondly, good daylighting in building is also important for reducing energy demand. The main facades are oriented south and north in order to let more daylighting go inside the room. High glazing ratio and triple glazing have been used in the design to balance the daylighting and heat loss through the window.
What's more, teaching spaces around the courtyard could also increase the daylighting factor, at the same time giving students more places to socialize. Finally, MVHR is also an important way to reduce heat loss through the ventilation, save more energy with the heat recovery and still ensure the indoor air quality. In order to increase the energy efficiency, we choose LED light instead of the fluorescent, which could reduce nearly 3 times of electricity in the artificial lighting. We also focus on the renewable sources. Because of the solar irradiance and the rainfall, we propose to have solar thermal system and rainwater harvesting facilities. Due to the vast site area, ground source heat pump is a reliable system that could be used for heating. CHP can also be used in combination for heating. COP ground source heat pump system is found to be 3 times more than the conventional system. Furthermore, the material we plan to use are locally available. Recycled concrete, straw bale, hempcrete and timber, which are renewable and low carbon. Additionally, it could also reduce the carbon footprint in construction. Based on Sapphire software simulation, the annual energy consumption, assuming use the standard HVAC system, is 84 kWh per square meter. It is below the 2013 target, which is 89 kWh per square meters.
We decide to choose natural ventilation and mechanical ventilation with heat recovery to provide enough fresh air for students and teachers. For construction materials, in order to provide a healthier built environment for children, low VOC or zero VOC coatings are chosen in our design. To satisfy the requirement of comfort, we use zone control for buildings in different functions. Temperature and lighting sensors are used to automatically adjust the built environment into a comfort condition. Our future target is to increase the energy efficiency of our design and give the detailed approach for renewable sources technologies to meet the energy target of passive house.